Hey everyone, it's Mrs. Fellon. I am going to talk to you today about graphing and transformations of both exponentials and logs. I'm going to do two videos. One's for just exponentials and one for just logs. I made this little table, and it's kind of a replica of what is in the Big Ideas book if you looked through the actual e-textbook. But basically, it's just a chart that kind of outlines the different kinds of transformations we're going to talk about. And then I'm going to give you examples of ones for exponential, what that looks like, and ones for log. If you want to go ahead and make a chart like this or include this in your comp book, you are more than welcome to do so. All right, let's get started. So the first translation we're going to talk about is a horizontal translation. This one is fairly common. This is one that we've seen in other kinds of translations and other types of functions. So for example, you might see something like a horizontal translation shifts your function left and right. So if it's an exponential, it might go like 2 to the x plus 1. That would shift this to the left, 1. Or you might see something like g of x and then 2 to the x minus 1, which would be a horizontal shift to the right. So remember, with the horizontal shift, this h value, remember that we're adding here, kind of does the opposite that we think it should do. So the x plus 1 means it's going to the left, and the x minus 1 means it's going to the right. All right, next one is vertical translation, and that's the one we're also it's very familiar with our other functions that we've talked about. So for exponential, it shifts it up and down. So if I give you a function like, let's say 5 to the x, and I said I wanted to shift it up, I might add 2. This would be shifting it up. And then if I gave you an example of shifting it down, it might be 5 to the x minus 2. So again, that's your k value. So what's important there is your k value kind of follows the pattern you think it should. If it's plus, it moves it up. If it's negative, it moves it down. And just remember that your k value is also where we're going to be using as our asymptote when we graph our exponentials. All right, so then we get into some other ones. The next one is a reflection. So there's like a flip, basically, over the x-axis or over the y. So there's two different ones, and so your function might look like if I had, say, negative 3 to the x. So what that negative out in front does causes my graph to flip in the x-axis. So basically what it's going to do is going to shift or flip this direction. So think about it like flipping up and down. And then if you have your function that looks like this, where the negative is kind of attached to that x, that's where your flip is going to be in the y-axis. So again, think about kind of going left to right. So there's two different kinds of reflections depending on where that negative is located. All right, these are probably the harder of the kinds of transformations that we're going to talk about. And this is going to be horizontal stretch and shrink, and then vertical stretch and shrink. So the horizontal stretch and shrink, and again, you might want to see here it says like stretches away from the y-axis or shrinks towards the y-axis. So an example might be something like this. So if I give you a function and I say like 4 to the 3x. So first of all, I'm going to give you two different functions here. And so the second one I'm going to give you is 4 to the x over 3. So notice the difference about where the number is located. So first, if it's being multiplied by this x, or if in this case it's going to be divided, so the number is like x divided by 3. So if it's being multiplied, we actually call that, you would think that would be like a stretch, right? It's actually kind of the opposite. This would be a horizontal shrink, and this would be by a factor. So I'm going to put by a factor of 1/3. So it's kind of the exact opposite, or think of it like a reciprocal. So this 3 here represents a horizontal shrink, and it's a factor of 1/3. This one, where it's like x divided by 3, would be your horizontal stretch. And this is by a factor of 3. So again, kind of opposite. It looks like it's kind of this should be 1/3 and this should be 3, but it's really kind of the opposite. And so that really only holds true for that horizontal. So remember, horizontal means left to right. So it's like, imagine you're pulling it left to right. So pulling that exponential graph either left or right. And so it's causing the graph to either shrink or stretch. All right, last transformation. We have a vertical stretch or shrink. I think this one's a tad easier. So if I give you an equation like 2, 3 to the x, or if I give you an equation of like 1/2, 3 to the x. So both of those are going to represent a vertical stretch or shrink. So notice horizontal has to do with the number being multiplied or divided like by the x. So it's either you're multiplying x by a number or you're multiplying x by like a fraction or dividing by 3. Whereas here, this is really your initial value. That's that number that's out in front. So I've often called that the initial value. This means your vertical stretch or shrink. So again, it's kind of like, imagine you're pulling it up or pulling it, like you're pulling it up 2 for every 1 vertical, kind of like a slope, if you would. So this one is going to be a vertical, this one kind of matches the way you think. This would be a vertical stretch by a factor of 2. And this is going to be a vertical shrink by a factor of 1/2. And so what these factors kind of come into play is when you're going to actually graph points and you're going to have to figure out like your table. All right, so these are all the transformations. We'll do the log one next. When I do the log video, let's talk a little bit more about some of what you're going to be expected to do. All right, so now we're talking about understanding transformation. So all I'm really getting at here is I want you to kind of be able to tell what does each value do in our problem. So the first thing I want you to notice is this 3. I want you to recognize that it's exponential, number 1, but more importantly, I want you to know that it's exponential growth. Remember, it's growth if that growth factor, that number there that's being raised to the x, is larger than 1. This plus 1, what does it do to my graph? Well, it shifts it up 1. That was that vertical translation. Remember, this is also your asymptote. So I'm just going to put that here just as a reminder. So you'll be asked in your practice today to kind of talk about the transformations and how they relate back to a parent function. And this is what I'm asking you to do, is just kind of explain how is this different. So basically just talking about the translations. All right, I wanted to talk about an e function because remember, e is just a different kind or a special kind of exponential. So this negative right here, if you remember with an e function, that's how you tell if it's growth or decay. So this is still exponential, but this one represents decay because of that negative. If the x were positive, it would be a growth. If it was negative like it is here, it's decay. This plus 1, that's going to be your shift left or right. And since it's plus 1, we're going to shift it to the left 1. And this minus 2 is going to shift it down 2. And again, remember, this is an exponential function, which means that k value is your asymptote. So I'm just going to note that. And the last one on here is talking about, so I got a lot of things going on here. So first, this negative number out in front, that's going to be your reflection. And if you remember, that's a reflection in the x-axis. This 1/2 is your vertical stretch or shrink. So in this case, it's a vertical shrink, and by a factor of 1/2. I mean, that's kind of obvious there, but we'll mention it anyway. This represents growth. Normally, that's not going to be different from your parent function because they're probably going to give you like 3 to the x. But I also want you to represent this 2 here. That's going to be a horizontal shrink by a factor of 1/2. So lots of fun things going on in this one. A horizontal shrink by a factor of 1/2, a vertical shrink by a factor of 1/2, a reflection over the x-axis. So we've got kind of, like I said, kind of a lot of things going on. So there'll be a section of your practice where it asks you just to kind of describe transformations. All right, let's get into some graphing. So next, what I'm going to ask you to do is I'm going to ask you to graph each kind of, I'm going to go through 3 different kinds of functions. And so these are all exponentials, and I wrote down the steps at the bottom of your page here, so you're welcome to include those in your comp book, or you can just kind of pause the video here. Basically, step 1 says find the asymptote. So before I do anything, I look at my function, I recognize that it's exponential growth, and I recognize that there's a k value of +1. So what I'm going to do is I'm going to go ahead and put in my horizontal asymptote there at +1. All right, next step. If you go to the steps down here, it says find the initial value, then translate it. So remember, the initial value is the number that's kind of being multiplied by whatever's being raised, like by the value that's being raised to the x. So it's not the 3, it's the number out in front. So in this case, it's 1. What I do is I put an x on the y-axis at that initial value. So in this case, it's 1, and then I translate it. So because there's a translation of up 1, that's why you put an x here, because I don't want to put a dot, and I moved it up 1. So that's what we call our translated intercept. I'm just going to write that down. So what that basically means is that we, in relationship to the parent function, this is how we moved that initial kind of y-intercept. We moved it up 1. All right. We are going to ask that you make a table and then find at least, so you use the translated intercept and then find at least 2 other points, plot the points in graph. So I'll show you how to do that. So on my table, I'm just going to go 3 to the x plus 1. I'm going to start with that translated intercept, which is at the point 0, 2. And so I should know that if I plug in 0 here, 3 to the 0 is 1. And 1 plus 1 does give me 2. So that's how I got that point 0, 2. So let's do a few more. Let's just do 1. 3 to the first power would be 3. 3 plus 1 is 4. And then let's do number 2. We'll pick 2. So 3 to the second power is 9. 9 plus 1 is 10. You don't have to include every point on your graph. You can try to. So like here, I'm going to do 1, 4. And that's pretty much what I'm going to be able to get on mine. And then 2, 10 would be like somewhere way up here. So again, you should recognize that this is growth, and that if you connect the dots kind of using that smooth curve, it goes towards your asymptote. That's what your graph would look like. All right, got 2 more examples for you, and then we'll be done. All right, so the next one is an e function. Again, I wanted to show you this one just because I want you to remember that it is no different than graphing a regular exponential. So in this one, I want you to notice that this +1 is going to make my graph move to the left 1, and this -2 is going to cause my graph to shift down 2. This is also my asymptote. So the first thing I'm going to do is I'm going to throw in that asymptote at -2. This represents exponential growth. I can tell that because the x value, it's e to the x and not e to the -x. Okay, my initial value, the number out in front here, is 1. So I'm going to start at 1. I'm just going to put an x there on the y-axis, and then I'm going to shift it. So I'm going to go left 1 and down 2. 1, 2. So I end up at this point here, which happens to be the point -1, -1, I think. Here, -1, down, -1. All right, so I'm going to go ahead and grab I'm going to have to use a calculator for this one. So I'm going to have, this is my table. So if I plug in the point -1 for x, if I plug in the point -1, I should get e to the 0 power. Well, anything to the 0 power is 1, and 1 minus 2 is that -1. So that gives me that value. All right, to get 2 other points, I want you to grab your calculator. And to go ahead and plug this in, what you're going to do is, let's say we're going to plot the point 0, for example, because I know it represents growth, right? So I know it's going to go up this way. So let's pick an x value over here. So let's pick 0 and +1. So if I plug in 0 in for x, I get e to the first power -2. Well, I don't know what that is off the top of my head, so I'm going to go ahead and grab my calculator. I'm going to hit second and then the ln button, which is right there. And I get e, and then I'm going to plug it into just the first power, and I'm going to subtract 2 from that. So I get about 0.72-ish. Next, I'm going to do the same thing, but I'm going to plug in 1. So I'm going to get e to the 1 plus 1, which is e to the second power minus 2. Again, I'm going to go to my calculator, e to the second power, and then, whoops, and then I'm going to go minus 2, and I get 5.39, roughly. All right, now that I have my points, I'm gonna go ahead and kind of sketch as best I can. So at 0, I'm gonna probably graph about right here, which is about it is about 0.72. And then when x is 1, I wanna graph at about 5.39. So 1, 2, 3, 4, 5, 6. So maybe about right there. Again, this represents growth. So I'm gonna go a nice smooth curve, and it looks like that. All right, last but not least, I wanted to do one that was decay, so I changed this to a 1/3. I wanted to show you a reflection, and I changed the initial value to something other than 1. All right, so on this one, same deal. Start with your asymptote. So there is no k value, so that means my asymptote is right here at the origin, or right there on the x-axis. Next, I'm going to go ahead and plot my initial value. So in this case, you can do this a couple ways. I'm going to plot the initial value at -3, so down here, and then I'm going to translate it. Well, there is no transformations. I didn't move it left or right, and didn't move it up and down. So I'm just going to leave it right where it's at. And then I'm going to go ahead and grab my, a table for this. So I'm going to 1/3 to the x. So I know that my translated intercept is here. So if I plug in 0, I should get -3 as an output. So let's try that. So if I do -3 times 1/3 to the 0 power, anything to the 0 power is 1. 1 times -3, you got it, -3. If I plug in 1, I would get -3 times 1/3 to the 1. Well, 1/3 to the 1 is just 1/3, and 1/3 times -3 is just -1. So I'm going to plot the point 1, -1 on my graph. And then the third point I'm going to do is I'm going to plug in 2 for x. So I get -3 times 1/3 to the second power. 1/3 to the second power is 1/9. 1/9 times -3 would give me -1/3. So that means if I plug in 2 for x, -1/3 would be about, I don't know, like right there, roughly. So if you can kind of see the way it's curving, your graph is going to look like that. Again, it has to approach your asymptote and curve down. All right, that's graphing exponentials with transformations. Thanks, everyone.